Okay, welcome to Chem 2A. We're just going to get started in a few minutes here, give everybody a chance to come in. A couple of things as you come in, your microphones and stuff should be probably muted so we don't talk over each other. Also, you should be able to see a chat box bottom right there, or wherever it is on your screen. That's again where you can type questions. That's probably the best way to do so. And again, as we wait for people to come in, we'll get started talking about a whole bunch of stuff. Just in the meantime, somebody wants to a couple people want to type into the chat so you can hear me okay. That'd be good to check everything. How you doing? Perfect. And again, since it's the first time, we'll give everybody a little bit of time to come in. Excellent. Sounds like everybody can hear me. I appreciate it. So again, a reminder, we'll get started. Give everybody a few more minutes to kind of come in. A couple of things are on your screen you should hopefully be able to see. Just a reminder that all these online live lectures will be recorded and posted eventually on Canvas, or maybe even a link over there to your YouTube. If you also could take your camera off, everybody, because it throws up a whole bunch of boxes on my screen and it's really hard to kind of see things on my end. So if you guys could also keep your cameras muted and shut off, I'd appreciate it. So again, it looks like a lot of people are coming in, so that's good. Again, as you come in, your microphone should be muted. If you also keep your videos muted, again, they pop up a whole bunch of stuff on my screen, and before I know it, I can't really see anything on my screen. I appreciate it. Also, with that being said, remember that if your microphone should be unmuted, if you want to ask a question or something that way, or it gets unmuted, we all could hear you. So keep that in mind. So as I was saying, again, these will all be recorded. I know there's a lot of things going on. So if you can't make it to the live one or listen into the live one, it will most likely be posted up there on a Canvas site, or at least a link perhaps to go watch it somewhere, maybe on YouTube or something like that. But they will be posted online. So again, you could watch them or rewatch them if you wanted to at your convenience. The recordings typically will show everything that you see on the screen. Anything that I show you through screen sharing will also show up on the screen and in the recordings. Anything that I write on the screen will be captured on those recordings as well. So, you pretty much see everything that you see as I'm doing it if you watch those recordings back. And again, if you're just coming in, please try to keep your cameras off. I appreciate it. All right, so just let me get started. Again, others come in. Hopefully everybody looks like that's here, saw the links on Canvas to get in. And for those just coming in, again, your mic should be mute and your video also will be mute. If you do have a question or anything that you want to hear or ask a question, you can use the chat box on the bottom there of your screen. You can type it in and I will answer your questions. Again, you can send it to everybody. You can send something privately, I think, to just me or others, and it'll be labeled that way as well in terms of the chat. Because these are online and everybody's sharing together and will be posted, remember, please be respectful in any comments as you make. Just be respectful of everybody's feelings. Any videos and audios that are posted online, again, are for your own personal use. Don't go repost them anywhere else. They're just for you to use for this class. Okay, so as you know, we moved 100% online, both the lecture and the lab as well. So I saw yesterday and over the weekend, Dr. Tyler was sending out some announcements through Canvas. My understanding is that's how she will continue to sort of get in contact with you through our Canvas site that just opened up as well in the last week. On the Canvas site, again, she should be able to post you, and I think I saw as well, her links to her lab sessions. My understanding is, and again, follow any direction that you get from her in an announcement, but my understanding is, again, if you have Monday lab, you would obviously go to her Monday labs meeting. And if you had Wednesday lab, you would go to her Wednesday lab meeting, just like you did in person, except you'll just be doing it online. I believe she'll also post up some maybe PowerPoints or information on the labs that you're doing. And she'll post up some assignments. So if you go to our Canvas page, you'll find some new stuff on there. So towards the bottom of the module section is where you'll find the lab. And again, it is broken up by lab day as well. So Monday lab and Wednesday lab have a separate sort of section on there. Let me see here if I can kind of go there with you. Do that. And again, so if we go to our modules page here, perhaps it loads in. There we go. Let's see. So here's our lecture information. So I made a little title, everything underneath lecture. Here's again where you can find the links if you didn't go through ConferZoom to our lectures that are live. Here's also where I'm going to be posting the lecture notes, similar to the stuff that I would normally hand out to you in class. So you could look on here and use them however you like. Again, if you watch the video, everything will be on there. Or if you're wanting to have them take notes like normal, you can. So these are some of the lecture notes that you can find. And then our normal stuff here, some review material. And then here's again the lab information. There's the Monday and the Wednesday sort of section. So you want to make sure that you get the correct section there. All right. And then in terms of lecturing, we will continue in terms of lecture, having them at our normal time, Monday and Wednesday, about 7:35. And my thought process there is just most people were available during that time. So hopefully, I know things have changed a lot for people, but hopefully most of you will still be available during that regular time. So if you want to come and listen to the lecture live during that time, 7:35 to 9, I would highly recommend you do so. Again, that's going to give you an opportunity to hear it live. Also give you an opportunity if you did have any type of questions or anything like that, that you'll be able to ask those questions and get them answered. And again, excuse me, the chat box is probably the best way to sort of ask those. If I see a message come through, I will read sort of the question, and that way everybody will know the question, but I think everybody will see it if you send it to everybody. And then we can kind of answer questions and ask questions that way. I think that's probably the best thing than using the mic. So again, we don't have everybody sort of talking over each other. Any question? Any questions on that? Now, in terms of the exam that we did have scheduled for this week, it has been postponed to Monday, I believe. Is what I scheduled it for, and we will take it. It obviously will also be in an online format. So as of now, my thought on that is you're going to take it most likely through Canvas. So you'll have a certain amount of time to take the exam. On Monday, it'll probably open up somewhere around when lecture starts, maybe 7:30, 5 in the morning, and we'll have some time to take it. You'll also have a time limit to take it. And I think there will be a component where there will be questions where you need to show your work. So you'll need to kind of write your work down and then upload your work to me through Canvas. So at least I could give you some partial credit just in case the answer that you give is wrong and stuff like that. So as of now, that I think that is sort of how the test is going to be done through Canvas. You'll answer the questions through Canvas, and you will sort of have to upload your kind of work like you normally would have to show your work. Yeah, I believe I moved it to Monday of next week, so I'm not even sure what day we're at. We're at 23, so probably like the 30th of March is when I think the first exam will be taking place. And again, as the week goes on, I'll post some more information about it up on Canvas, but that is my guess as to what will happen in terms of the exam. Any questions on the exam or anything like that? I think I also moved the online homework in terms of when it's due, but you should hopefully have that done by now, or at least get it done. Make sure that you do complete that. So I think it might be due. Might have moved it originally to the end of this week on Friday. So hopefully most of you have worked through that. But remember, you still have the online homework that needs to be completed. So make sure that you do take care of that as well. Any questions about the class, how it's going to sort of go from this point on? Then that sounds about right. I think I might have moved it to the end of this week. Again, that's been up there for the beginning of class, basically. So make sure that you do finish those homework. And again, it will help you for the exam that's happening on Monday. So I think somebody said it's the 27th, which makes sense. I think that's Friday. So in terms of the test, again, like I said, it will be online. So you'll log into Canvas and there'll be kind of an exam or a quiz where it will obviously only give you an opportunity to enter the answer to the question, is how I envision it probably happening. With that being said, because we usually like to give you an opportunity to kind of show your work and maybe get some partial credit, what you'll also be required probably to do on problems where there are work to be shown is to kind of write it on paper, and then you'll have to upload those paper. The exam will still be only on what it was originally going to be on in terms of topics. So that I believe for us is chapters 1 and 2 should be the only chapters that will be on there. I think we were right in the start or middle of 3 when we got cut off. So right now, again, just chapters 1 and 2 like normal. So if I remember, that should be your sig figs, your density, your conversions. I believe they're out of chapter 1. Also, I think chapter 2 was the atom, electrons, protons, neutrons, atomic number, mass number, electron configuration, and the periodic table, I believe, in chapter 2. So chapter 1 and chapter 2 will be the exam that should take place 1 week from today online at our Canvas site. Which is March 30th. And again, it will be probably given also during our normal time period, just like if you were going to take it in class is most likely when it will be up there for you to take. And you'll have obviously a private amount of time to sort of take those exams. Any other questions on anything like that? Any questions on the class or anything like that? The online homework is still on our sapling site. So we're still using that in terms of homework for the lecture part. So that has not changed. So that's the same as it was at the beginning of the semester. The online homework for each of the chapters will be up there on that sapling site. And again, if I'm not mistaken, I think the entire semester's worth of homework should already be posted and available for you to see. So you should be able to see that. So in terms of our Canvas site, that is where you will find pretty much everything other than the lecture homework. So on the Canvas site, you'll find, again, any type of exam review material. You'll also find lecture notes in terms of the lecture part. Any type of worksheets from this point on will be probably strictly posted on the Canvas site. Any type of review worksheets or anything like that for lecture. Review topics will be posted up there as well. So everything in terms of lecture pretty much will be on the Canvas site. We'll now just go back to using the sapling site for just pretty much just the online homework like we had been from the beginning of the semester. Again, Canvas will also be the place where you can find anything related to lab as well, or anything that Dr. Tyler perhaps posts up there or will need to get to you. That is where you will find all of hers. So I believe all of her lab stuff will be on Canvas, in addition to maybe somewhere else you might have to go, but she will definitely let you know in the announcements. But a majority of everything that you'll need will be on Canvas. And I believe that's also where you, for lab, where you will submit your labs is through the Canvas site as well. So in the Canvas site, there should be a spot that's like not announcements, assignments. And in the assignments part should be a part where you can upload files, and those files can be uploaded in that site. And that's how you'll basically submit it. In terms of the exam and submitting sort of your work, it'll be done the same way. There'll be a little spot in sort of the assignments section where you can submit your work for the exam next week. And again, that could be in a format of PDF or some file format like that. PDF might be the easiest for most people. I think there's a lot of phone apps out there. Maybe Adobe has one as well that are sort of free, that you could kind of take pictures of your papers and then kind of turn it into a PDF file, which might make it easier for you to upload, obviously, on our Canvas site. Other questions about anything in terms of the class or how it's going to run? Also, a reminder that my regular email still works. So if you have questions when we're not here together, or at some time today, other times throughout the day or throughout the week, you could always still email me at my email, and I will get back to you. In terms of attendance for the live meetings, again, I know there's a lot going on for everybody. So not necessarily going to impact your grade or anything like that, but I think it's highly recommended that you, if you can, still kind of come to the live lectures. Again, it's a way for you to kind of see the lectures live. And if you have questions, it's again a way that you can kind of get those questions answered in the context of what we're talking about at that moment. Watching it back, you may have a question, obviously not have a way to sort of get that answered at that moment while you're watching it. So if you can do it, I would highly, highly recommend that you do come live, or at least as long as you can. Hang out here in terms of the live broadcast so you can get those questions answered. Again, because of everything that is going on, if something should happen, you can't make it to one of those live lectures, then they will be posted in some fashion. My best guess now is there will be probably a link to maybe a YouTube video where you can, again, re-watch these recordings. If you were here live, you could watch them, or if you weren't able to be here live, you can see the recordings. And again, the nice thing about the recordings, like I said, is you'll pretty much see everything that's on the screens. So again, here, if I were to write something, on the screen or kind of annotate on the screen there or something, you'll be able to really see it and stuff like that. So all this stuff that I'll eventually kind of scribble here on the screen as we go through these slides, you'll be able to see in the recording. So all that stuff that's written, you know, you won't miss anything in terms of that. Just to make sure the screen still works there. Any questions on any of that there? Okay, so I think that covers most of everything that we're talking about in terms of this class and sort of how it runs. So I guess we should get to actual lecturing. So again, you can find these lecture notes if you sort of want to print them out or use them, you know, through your computer as well while you're watching it, or however you want to do that. Again, I'm going to post them up there on our Canvas site underneath the lecture part, and again, you'll have access to them. They'll be very similar to the ones that you were given, you know, in class in person as we went along. So we will continue on, and if I'm not mistaken, we are on chapter 3 here. And in chapter 3, we were talking about ionic compounds, and in ionic compounds, we got through, I think, sort of Lewis dot symbols. We talked about sort of drawing electron dot symbols for things that are ionic compounds. So let's just kind of talk about a couple of things. So when we talk about ionic compounds and we talk about sort of nomenclature, here's a table that sort of describes what happens when we talk about naming these guys. And just give me 1 second here. I'm just gonna stop sharing for just 1 second. I'll put the screen right back up. On here. There we go. Okay, there you go. Got everything back up. Okay, so when we were talking last time, we were talking about ionic compounds, and remember that ionic compounds are really between a metal and a non-metal. And when we look at an ionic compound, when those two guys do get together, as we talked about in that previous chapter, the result is what's going to happen is we're going to get a transfer of electrons from our metal to our non-metal. And when we get that transfer of electrons from our metal and our non-metal, it's going to create basically two things. It's going to create a cation from our metal, and it will create an anion from our non-metal. And this is going to be a result of them gaining or losing electrons, and our cation will become positively charged. Our anion will become negatively charged. And it again is that attraction between the positive and the negative charge that holds that together. There's absolutely no sharing of electrons here. It's just that electrostatic attraction. And again, that electrostatic attraction is the opposites attract. So it's the positive, negative attraction that occurs. And that is what holds that together. So the important part here again is no sharing of electrons. When we do have an ionic compound. And when we do talk about those guys, and we do talk about sort of naming just cations and anions, when we name cations, we pretty much just use the whole name. So if we had Fe2 plus, this would be the iron Roman numeral 2 ion. We had Na plus, this would be the sodium ion, and so forth. So when we have just our cations that are present, we essentially just use the entire name of the element. And when we talk about our anions, those are a little bit different. Those end in the IDE. So at the end there, they will end with IDE. So we use sort of the first part of the name, and then we will basically drop the last part and convert it into IDE. So if we come up here and we look at something like O2 minus, that's oxygen, it becomes oxide. If we have S2 minus, that becomes sulfide. If we have Cl minus, it goes from chlorine to chloride. So these guys all will end in the IDE. That's a really bad O there. We'll connect that. And we get the IDE. So that's basically how we kind of simply name either cations or anions. And again, this table right here sort of shows that. It shows the way that we name both the cation and the anion. Yeah, so a question was, they don't have electrons in common. Yeah, so when we're talking about an ionic compound, there's absolutely no sharing of electrons that occur there. There's just simply electrons that have been transferred from the metal to the non-metal. So that is always the case in an ionic compound. The metal will always lose those electrons because of all those periodic trends that we talked about. Again, they're more apt to get rid of their electrons. They don't really want to hang on to electrons or attract electrons. And that's opposite for those trends for our non-metals. So if you remember on the periodic table, our non-metals are upper right. So those guys in the upper right part of the periodic table have all those trends that we talked about that basically make them want to gain electrons, bring electrons towards themselves, and basically not give away their electrons. So if you remember, nonmetals have very high ionization energy, which means it takes a lot of energy to remove electrons from a nonmetal, and that typically doesn't happen. While metals, on the other hand, which are kind of to the left and right, to the left on the periodic table, typically have low ionization energy, which means it doesn't take a lot of energy to remove electrons when we're talking about those metals. So that's why we typically, when a metal and non-metal get together, what happens is we do get that transfer of electrons from the metal to the non-metal. And it's that attractive force between the positive and negative that holds that unit together. And there's absolutely no sharing of electrons in common with them. So if we look at this table over here, we see, again, these are all positively charged ions. And if we just need to name just the cation by itself, which is our positively charged, we simply just use the name of the element, and we typically would just write ion after it. So for example, over here, this would be the hydrogen ion, the lithium ion, and so forth. If we were just talking about this guy over here, our H plus, our Li plus. Now over here, when we look at it, for our negative guys, these all end in our IDE. And when it ends in our IDE, that means that it is negatively charged. And we still use the first part of the name, as we can see there. We just really drop that last part and put the IDE. Sometimes it's, most of the name, some of the name, a little bit of the name. There we have bromide from bromine, chloride from chlorine. So when we put sort of simple guys together, for example, if we took the sodium and the chlorine, it becomes something like sodium chloride as to how we put them together. So again, if we were just to name our negative guys, this would be the hydride ion, the fluoride ion, the chloride ion. Now, hydrogen there is different. It is essentially the only one that could kind of go both ways. So hydrogen can be +1 in certain cases, which means it would be the hydrogen ion like it is there on the left. It could also be -1 in certain cases, which means it would be the hydride. Typically, if it is going to be -1, it will typically come after a metal. So typically if it comes after a metal like lithium, that would be something like lithium hydride. In that case, that is basically a combination there of lithium that's +1 and hydrogen there that's -1. And that's why they come together and would have that name. Any questions on that there? Okay, so let's see here. So what we were talking about as well last time is that when we put together something, for example, like calcium and like fluorine, which is -1, when we put these guys together, and any ionic compound, when we put them together, we always want the charge to equal 0. So the overall charge in the compound when we put it together does need to equal 0. So in this case, when we look at it, we have +2 on this side. We have only -1 on this side. So to balance it out, we actually need not 1F minus, but we actually need 2. And that would give us a grand total of -2. So this -2 and this +2 here will balance each other out. So when we put them together, we will get that formula of CaF2, which is again calcium fluoride. We'll talk about that in just a second. Same thing again if we took something like aluminum, which is +3, and oxygen, which is -2. Again, when we put that together, the common number there is kind of 6. So in order to get the aluminum to 6, we need not one of them, but we do need 2 of them. And that would get us 2 of those guys in the formula. And to get our oxygen here to 6, we need not 1, not 2, but we actually need 2, 4, and 6 of them. So that would get us 3 total in terms of the number that we need. And that would give us our correct formula there for aluminum oxide. Again, we always want to balance a formula here that is ionic. So although it does not here have any type of charge in this formula of an ionic compound, it does still represent 2 things that have a charge. It represents that you have calcium with a +2 charge, that's your cation, and it represents that you have fluoride there, which is a -1 charge, and that would be your anions. So always in a ionic compound, you'll never have any charge written in the compound, but again, it still implies that you have 2 things that does have a charge. So in this case, our cation would be aluminum with a +3 charge. Our anion there will be oxygen with a -2 charge. Any questions on that? So I think we talked about kind of putting those guys together ionic, metal, non-metal, cation, anion, always no charge when you put those together in terms of the formula. And you want to do that again in the simplest way to put it together to get you no charge. There's many ways you could kind of put it together to get no charge, but it does need to be sort of the simplest whole number way of putting those ions together to achieve that charge of 0. And when we do write these things both in formula and also in name, it always goes cation first, followed by anion. So that is both for when you name it and also when you write the formula. So always positive first and negative. So for example, the one we had before, you would not want to write it F2Ca like that. Although it is balanced, it's not correct in terms of the order. It should always go cation first, then anion. So again, that's just a little review there of sort of ionic compounds in general, how they come together. Let's take a look what we got next here. So when we talk about these guys, we talk about type 1 guys. So that's a type 1 guy is still a ionic compound, is still a metal and a non-metal. And as we talked about, it is the metal that's really the important part there. The metal here is going to be from group 1, group 2, group 3, or the metal may be zinc, cadmium, or silver. And why all those are important is because, again, they have fixed charges. So because they have fixed charges, and I think the next thing I got on there is a periodic table here. So this is a picture from your book. Again, when we look at it, remember that everybody in group 1 on the periodic table will make a +1 charge. Everybody in group 2 on the periodic table will make a +2 charge. And everybody there in group 3 will make a +3 charge. And to be truthfully honest with you, we're really talking about aluminum in most cases. That's usually the one that you'll see out of group 3. In addition, those guys always have fixed charges in terms of those positive. They'll never make anything other than those charges. So again, you'll never find sodium that has a +2 charge, a +3 charge. It can only have pretty much a +1 charge, no matter who it sort of hooks up with or bonds to. Always, no matter what the case, is going to be +1. Now coming the other way here, skipping group 4 and coming to group 5, we kind of go backwards again above the staircase here where we have our nonmetals, and group 5 is going to be -3, which is typically our nitrogen and our phosphorus. We will also go group 6, which is -2, and group 7, which is -1. So we sort of go in order there. We kind of go +1, +2, +3. Then we skip. We go backwards, -3, -2, and -1. And again, those guys are also fixed in terms of their charges. In terms of the metals, those guys in group 1, 2, and 3 will have fixed charges. But again, there are a couple here in the transition metal region that will also be fixed. So zinc and cadmium, you hang a leftover there to silver. So zinc and cadmium, although they're transition metals, they will always make a +2 charge. So this will always be +2. This will always be +2 when it does make a charge. And then if you hang a leftover here to silver, it will always be +1. So although these guys are transition metals, they also are considered type 1 metals because they have fixed charges. So zinc and cadmium, because of their fixed charges, will always have those charges. So our type 1 metals, again, group 1, group 2, aluminum here, and then our zinc, cadmium, and silver. Any questions on that? And again, a reminder, if you do have questions as we go through, you could use the chat box there to ask your questions. Also, I think there's a little hand you could raise if you want me to kind of come to you. If you want to verbally ask that, you can. I could undo your mic, but probably the best way, again, is you could type in the chat box would work well. All right. So when we talked about type 1, guys, and we talked about naming sort of type 1 guys, as we talked about last time, pretty much when we do have type 1, we always use the whole name of the metal. And then for the non-metal, we use the front part of the name and we add the IDE. So again, some of that we will drop off in terms of the non-metal name. So if we look at something again, like our sodium chloride, again, Na, which is group 1, which means it has a fixed charge. So that's all we have to worry about. So we again would just call it sodium chloride. And then if we had something like CaCl2, for example, again, Ca, which is calcium, Cl is chlorine, which is a non-metal, and calcium being a metal. Again, it's the calcium part that's the most important. Calcium is group number 2 on the periodic table, which means it has a fixed charge, and this would be calcium chloride. So IDE at the end for our non-metal, whole name here for our metal. And the thing that people commonly sometimes will mess up on is this part right here. Although there is a 2, you can see here it has no effect in terms of how we name the non-metal part. So even if there's a 2 there, there's a 3, there's like 500 there, it would still just be called chloride. So sometimes people in this situation want to use something like dichloride because they see the 2, but you should not do that. Again, you just simply put IDE at the end of it and call it chloride. Any questions on that? So again, if we did have something like, say, potassium sulfide. So if we're given the actual name and we want to write the formula, again, a reminder that what we want to look at is here, and we see potassium. So potassium, again, is group 1, which means it does have a fixed charge, and that means that that should be K with a +1 charge. Sulfide with the IDE here means that it has a negative charge, and sulfur being group number 6 means that it will have a -2 charge. So this again is our cation. This is our anion. And when we put it together to make our ionic compound, it's always important to put it together in a way where, again, we get 0. Now, sometimes people will say you could just do the switcheroo. You could just drop the 1 down there. You could drop the 2 over there on the bottom. And that does work. And it works, 90-ish% of the time. But in some cases, it may not work. So you want to think about just what's the easiest way to get to 0. So when we look at this, we got a +1 here. We have a -2 here. So again, we do essentially need more of the +1. We actually need 2 of them, and that would give us our formula of K2S. Any questions on that there? So let me just write up a couple here, and then we'll go over them. Why don't you think about what these guys would be? So let's say we had barium fluoride. Let's do aluminum oxide. And let's do sodium nitride. All right. I'm going to give you a couple minutes here. Why don't you write the formulas for those, and then we'll go over them. We'll see how everybody did. And again, if you have any questions, feel free to type them there in the chat box. So why don't you take a minute or two here and write the correct formulas for these guys, and then we'll talk about it. So what we're looking for here for is the chemical formulas for each of those. So see what you come up with. All right, so let's take a look here. So again, for this first one, we see barium and we see fluoride. So again, we just wanted to think about the two parts that make that up. So for example, for our barium, that is group number 2, so we know it has a fixed charge of +2. Our fluoride, which is basically fluorine on the periodic table, is group 7, which means it has a -1 charge. So again, when we put that together, we do need more of our fluoride. We need one more to balance it out. And that would give us a formula of BA2, I'm sorry, 2, BAF2 there as our formula. Again, that tells us we have 1 barium at +2, 2 fluorides, each at -1 gives us -1 and -1, which is -2. So everything is balanced out there. Now, if we look at the next one here, which is our aluminum. Aluminum here is group number 3 on the periodic table, so it has a +3 charge. Oxygen again, which is group number 6, has a -2 charge. So as we saw earlier, +3 and -2, the common number there is going to be 6. So to get aluminum to 6, we need 2 of them. 2 times +3 is +6. To get our oxygen here to 6, we need 3 of them. Gives us our O3. 3 times -2 is -6. So we have our +6 and -6. Everything is balanced. Any questions on those? Okay, so for the last one, here, we have sodium, and sodium is group 1, so it is +1. If I stop hitting the wrong button there we go. And our nitride is nitrogen on the periodic table, and that's group number 5, which means it has a -3 charge. So again, what I'm writing here are the basic cation and anions and their charges, and that's what you want to kind of think about when you want to put them together. So here, when we look at this, we have sodium with a +1 and nitrogen there with a -3. So we actually need more sodium in this case. So we would need 3 of them. Each at +1 gives us +3. And we would just need one of these guys at -3. And that would get us a formula of Na3N in this case. Any questions on any of those? So remember that if you are asked to write the chemical formula for an ionic compound, like what we did here, over here, and also down here, anytime you write the actual chemical formula, they should have no charges up on top. So there should be no charges written up here on top. You should only balance out those charges. So really the only numbers that you should ever have in an ionic compound in terms of the formula are these subscripts. So there should only be numbers on the bottom. And that's the only numbers that you should have in there. They should definitely have no charges when you put them together. Now, when you're asked maybe differently to write the formula for a cation or anion, so if you're asked to write the formula there for either just the cation or the anion. For example, if you were asked to write the cation in this case over here, this would be the formula for the cation. And it would need the charge because it is an ion. So if you're asked just to write the individual components, which in this case is the anion or the cation, you would include the charge because it would just be that ion by itself. But when you combine them together, they should never have any type of charge basically written in. Any questions on type 1 and put them together? So we also talked about type 2. So why don't you try to name this one here? If we look at this one here is K, which is group 1. And K, which is potassium, has a +1 charge. Cl, which is group 2. So as soon as you see that K, that is the important part here. It's always the metal when you have that metal, non-metal. And because that is group 1, we can simply just use the name of it. And that would be something like potassium chloride. Again, whole name of the metal, IDE there on our non-metal. Why don't you try the other two and see what you come up with in terms of the name, and we'll talk about it in just a second. Okay, so again, if we look at these guys here, we see zinc, and zinc, although it is not part of group 1, group 2, or group 3, it is a transition metal, but it's one of those 3 transition metals that we talked about, that is zinc, cadmium, or silver. Although they are transition metals typically have a variety of charges they can make. because it has a fixed charge, it's always going to be +2. And because it does have that fixed charge, we can treat it like a type 1 metal. And that means for this guy, we would just use the whole name of the metal, which is zinc. And our sulfur becomes sulfide, IDE at the end there. Any questions on that one? All right, then looking at our last one here that we have Ca, which is our calcium. And again, our calcium is group number 2, which means it has a fixed charge of +2. And because of that, that's pretty much all you need to go by. You could then just use the whole name there, which is calcium. And again, the Br, which is bromine, drop the last part and put the IDE at the end of it. And we get something like calcium bromide. Again, that 2 on the Br has no effect in the name. It would still would call it bromide, no matter if it was a 2 there, a 3 there, or anything like that. So a little review of type 1 that I think we were talking about there last time we were in person with each other. Any questions on that? Okay, so then as I was mentioning earlier, oh, there's one more. Look at that. Should do the whole page. On the bottom here, we'll take a look at this really quick. Again, we got Ba, which is barium. It's also going to be group 2, which means it's Ba2. In this case, that's a metal. That's all we need to worry about. Our non-metal, which is hydrogen, remember hydrogen is a non-metal, actually comes second in this case. So this is where hydrogen actually would be -1. And that is why there's 2 of them, because we need 2 of them to get to -2 to balance out the +2 that we have there. But really, again, we would follow the same thing. Because it's type 1, we would use the whole name there of barium. And in this case, because hydrogen is negative, this is where we would use that name that we saw earlier, which would be barium hydride. Okay, so now let's maybe get to type 2. So type 2, if we remember as well, I think we got into in terms of naming. Again, type 2 is also a metal and a non-metal. And just like type 1, it is the metal that's important. The metal here will be a transition metal. Are just to the right on the periodic table. Things like tin, lead, antimony, these guys, although they're technically not transition metals, they are also treated like transition metals. So let me actually pop up a periodic table really quick. I'm going to stop sharing for just a sec. And then all right, so let's take a look at this periodic table here. So when we're talking about type 2, guys, what we're talking about really is our transition metals. Oops, come back. There we go. And do this. So when we talk about these guys, we're talking about our transition metals here as being type 2. Again, except for really these guys here. These guys are really type 1. Let's put a 1 right there. So these guys are basically type 1 in terms of naming. But everybody else here in our transition metal region, and when I'm talking about just to the right as well, are things like lead, things like tin, antimony, bismuth. These guys are that are to the right, but kind of below the staircase that runs, through here. These guys as well are considered type 2 guys. Again, even though they're not technically transition metals, they're pretty much named the same way. They have this same ability to create basically multiple types of charges. So when we talk about those guys, right here, our type 2 guys have that ability to basically create a variety of charges. So it does matter in their case who they are connected to in terms of the charge that's happening. But in terms of naming, it's still basically the same thing. We're still going to use the whole name of the metal. The nonmetal will still get that IDE at the end of it, drop a little bit of the name and put the IDE. The main difference between this and the type 1 is here we will use Roman numerals. So we will use a Roman numeral, and what the Roman numeral basically indicates is the charge on the metal. And that again is going to be the positive charge on the metal. Not the total charge that you have, not how many metals that you have, but it's the actual positive charge. If you just took one of those metals out and basically what the actual charge was on it. So for example, if we looked at something like FeCl2. So when we look at Fe, which is a metal, Cl, which is a non-metal, again, it's going to be an ionic compound, but it is our iron here. That's a transition metal, which means because it's a transition metal, we're not 100% sure what the actual charge is on it. But the good thing is you'll always know the non-metal, what the charge is on the non-metal. And in this case, chlorine is group number 7, which means it has a -1 charge. And there's not one of them in this formula, but there's actually 2 of them in this formula. That gives us a grand total of -2. And since there's only one iron in this formula, the ironwood has to be +2 to balance it out. So when we go for the name, it's still the same thing, the whole name of the metal, which is iron. Here we put Roman numeral 2. And again, the 2 is for the positive charge that's there. And then this becomes chloride. Yeah. So iron, Roman numeral 2, chloride. And really, again, the 2 there is the charge on the metal. It is needed to tell people that in this particular case, we're talking about iron with a +2 charge. And that would be different, as we maybe did as well last time, if we had this example, FeCl3. And FeCl3 tells us the same thing. Again, we have iron. That's a transition metal. So we're not sure what the charge is. But in this case, we don't have 2 Cl minuses, but we actually have 3 Cl minuses, which gives us a -3 charge. So in this case, our ironwood has to be +3. Yeah? And that means that the name for this guy would be iron, Roman numeral 3, and again, chloride here. And again, the 3 is for the +3 charge that we see on the iron. So really type 1 and type 2 are very similar in terms of how you name it. The only distinction between them is because that metal in type 2 is a transition metal or something like tin, lead in that area of the periodic table, because they have the ability to make multiple types of positive charge, you pretty much need to tell the person that's looking at it, hey, in this case down here, I'm talking about iron with a +2 charge. In this case up here, I'm talking about iron with a +3 charge. Any questions on type 2? And again here, just there's some examples of transition metals and their multiple charges. Obviously, everybody else as well has multiple charges. These are our common ones that are a little bit outside of the area of transition metals that are still named like transition metals. Again, a reminder that these guys are really not type 1, type 2, or I'm sorry, type 1, type 2 guys, they're type 1 ions. So zinc, cadmium, and silver do not need a Roman numeral next to it. So they do not need a Roman numeral. So again, zinc, cadmium, or silver, those are going to be named just like type 1. But everybody else in the transition metal and everybody to the right there for lead and tin or SN will need a Roman numeral. And here again is a table from your book. Again, we use the Roman numeral to indicate the charge. So there's a question about nickel. Nickel does need a Roman numeral. Nickel can have multiple types of charges. No, so let's just go back to that. Just so a little misleading here. These guys here, and again, it's from your book, but these guys here and here, which has sort of, sort of a fixed charge, if you will, on this table. It actually doesn't. So for example, nickel can make +4. Mn actually can have a lot of different charges like +4 and stuff like that. So really just those three that I highlighted over here, the zinc, the cadmium, the silver, they are the ones that will have the fixed charges in your transition metals. Everybody else will need some type of Roman numeral, including Mn and also nickel, Ni. They will also need those Roman numerals. So I don't know. I didn't make this chart. Your book did, but I'm not sure why they just sort of limited it like that. But those guys definitely can make multiple types of charges, both the Mn and the nickel. Other questions on that? Yeah. So again, when we put these together, type 2, just like type 1, they're both ionic compounds, which means they're both basically made up of a positive and negative charge. So when we put them together, again, the goal is to find the simplest common number that will get them to 0 in terms of their charges. And again, you want to do that in the lowest sort of numbers that will do that. A nonmetal will not always be -2 in terms of its charge. So when we talk about our nonmetals, again, in group 5, they will be -3. If it's in group 6, it will be -2. If it is in group 7, it will be -1. And again, what we're talking about in terms of the nonmetal charge, it's above the staircase here on the right where our nonmetals are. So -3, -2, -1. Your nonmetals can have pretty much any of those type of charges. Other questions? Yeah, and again, a little bit deceiving, this little chart that they made from your book. I think they were trying to show something, just that they can have multiple types of charges. They might even have in words like, these guys have fixed charges. But again, zinc, cadmium, silver, type 1. Anything else that you see in the transition metal region for our class, and to the right of the transition metal region, I'll spit that out, transition metal region, will also need Roman numerals as well. Other questions? Okay. So again, this chart was just kind of showing you another way that sometimes things that have multiple charges or type 2 guys are named. You'll sometimes see kind of this older school way of naming, which we will not use in this class. And they use something like OUS and IC versus the Roman numerals. And basically the OUS is the one that has the smaller positive charge. The IC is the one that has the larger positive charge. So for our lecture portion, we really won't use any of these names, but you should maybe be aware of them. Sometimes they will pop up in some places, but definitely not in lecture. Maybe sometimes in lab, they'll sometimes pop up. But here we'll strictly stick to naming things with the Roman numerals that are type 2 compounds. So remember that if we do have the name given to us, that is a type 2 sort of compound. So for example, if we had copper, Roman numeral 2, nitride. When we do see this name and we do see the Roman numeral, that automatically should tell us that we're looking at something that is a transition metal. So when we look at something here, it actually gives you a lot of information. If we want to write the formula, we know copper is Cu. And the Roman numeral 2 again indicates the actual charge on the copper. So it actually will tell us right off the bat there, the charge. Nitrogen, which is nitride, is group number 5. So because it's group 5, we know it will have basically a -3 charge. And again, when we put this together, just like we did with type 1, we want to get it together in the simplest way to get to 0. So the common number there is 6. So to get this guy over here, the copper to 6, we would need 3 of them. So Cu3. And to get our nitrogen to 6, we would need 2 of them. It will be N2 would be the correct formula. Just like type 1, we have no charges in the chemical formula when we write them. It is simply just putting them together in the simplest fashion to get to 0. Remember as well, although this does not have charges, it is made up of 2 things that do have charges. Our copper with the +2 is our cation, and our nitrogen with our -3 is our anion. We could also see in this particular case, if you wanted to, the kind of switcheroo would work. If you brought the 3 down and you brought the 2 over, we end up with a 3 and a 2, which again works in a lot of cases, but not 100% of the time does it work. So for example, if we had PbO2, why don't you take a second and come up with the name you think that is, and we'll talk about it. Okay, so if we look at this, again, we see lead, which again is not a transition metal, but it's one of those ones that are just to the right. So it is named the same way. And what that means is we're not maybe sure exactly what the charge is on it. So again, here, if we look at lead, we're not really sure. But here, the oxygen, which we do know is group number 6, has a -2 charge. And again, it's fixed for it. And that means that we have 1, and we also have 2 of them, which gives us a -4 charge. And that means in this case, the lead actually will be +4. And if we were to name this, because it is essentially named just like a transition metal, this would be lead Roman numeral 4, again for the charge. The oxygen becomes oxide. So a couple of things on here, just like in type 1, even though there's 2 here, we don't do anything like dioxide or anything here. It's just oxide. Lead here having the +4 charge. This is a case where, again, if you kind of crossed over and brought the 2 there and brought the 1 over there, you would end up with actually the wrong information in this case. You might call it lead 2 oxide or something like that. And again, you can see here it's actually lead 4. So in a lot of cases, the switch of those charges, like what we have over here, will work really well, but in some cases, it may not always work. So it's always best, as I think we talked about last time, to think about it in just that simple sense of I want to put them together so that the charges equal 0. Any questions on that there? So we have a few here to name. So why don't you give it a go on this? Give it a go, name those guys, see what you come up with, and we'll talk about it in just a second. All right, so let's take a look and see how we're doing here. So when we look at this first one here, again, we see CO, which is cobalt, and that is a transition metal, and Cl is chlorine, which is a non-metal. And because cobalt is a transition metal, that automatically should tell us it can have multiple types of charges. So we do want to look at what it's attached to, and Cl is -1 because it's group number 7, which means there's not 1 there in that formula, but 3. That gives us a grand total of -3. So that means in this case, the cobalt has to be +3 to balance it out to get us to 0. So we would name this cobalt, again, the whole name. Here we would include Roman numeral 3 for the charge. And the Cl will just become chloride. Again, even though there's 3, we don't put any type of prefix in front of it, and we end up with cobalt, Roman numeral 3, chloride. Looking at the next one, also we have Cu, which is copper. This is transition metal, so automatically it can have multiple charges. I, though, that it's bound to is group 7, has a -1 charge. So to balance that out, the copper here has to have a +1 charge. And what that means is we then would call it copper Roman numeral 1, again for the charge. And iodine becomes iodide, IDE at the end of it. Any question on those two there? And lastly here, we have SN, which is tin. And tin, although it is not a transition metal, it's one of those ones, as we were talking about, that's right in that region of the periodic table, just to the right of our transition metals, but still are named just like they were a transition metal. So we do need to figure out the charge. And here it's attached to Br, which is group 7, and that's -1. And again, we have 4 of these guys. If we drew them all out, you don't have to, but if we draw them all out, that gives us a -4. And that means that this guy is +4 to balance it out. And again, the whole name of our metal, tin, Roman numeral 4, again for the charge. And even though there's 4 of these guys, it is still going to be just bromide at the end. So tin Roman numeral 4, bromide. Any questions on any of those guys? Type 2. So very common mistakes that most people make with type 2 is they always want to, for the Roman numeral, use it to say how many metals there are rather than what it should be used for, which is the actual charge on the metal, the positive charge. Any questions on anything we talked about today since we're getting to the end? So we did spend kind of today reviewing a lot of what we talked about last time. So hopefully, obviously on Wednesday, we'll get into some new material. We'll also get into, I think, some of chapter 4. So right now, there's a handout up on Canvas of what we're going through right now. There probably will be one before Wednesday, so you might want to look for it as well. That will be like kind of chapter 4's handout that will hopefully get into some of that on Wednesday as well. So a couple of reminders here before we call it a day in terms of the lecture portion. Again, as we talked about, the exam will be next Monday in an online format through Canvas. And again, I'll try to post up some more information, or maybe Wednesday as well. We'll talk about some more of that. But definitely will probably occur on Monday. It will cover just originally what it was going to cover, which is chapters 1 and 2 only. That also means that on Sapling, you should still have the homework assignments that you need to do through Sapling. That's where all the homework will be, the same place as it's been since the beginning of the semester. You will probably have to upload some information in terms of your work on the exam, so I could give you some partial credit just in case you get the answer wrong. But again, that will most likely take place next Monday, the 30th, through Canvas. Probably you can start it around our normal lecture time. So we probably won't have a lecture on that day. You'll probably just take the exam. On this coming Wednesday, we will continue to lecture and go through chapter 3 and then into chapter 4. And in terms of everything else, again, the lectures will occur live Mondays and Wednesday about 7:35 when we normally start. And if for some reason you can't be here live, or you missed it or want to hear it again, at some point they will be posted up on our Canvas site, either directly on our Canvas site or a link to go watch it probably on YouTube or something like that. But they will be up there. Just a note on that, it does take a little bit of time to sort of process the video and get it up there. So my goal is hopefully by the next day at the latest sometime, that video of the live recording will be up there. So unfortunately, it's not instantaneous, but it does take a little bit of time to get those guys processed. So it will be up there. And again, you'll be able to find those links on the Canvas site. The question was, where the test be on Canvas and Zoom? At this moment, I believe the test will be run through Canvas, so you won't have to log on to Zoom to do it. You just have to log on to the Canvas site and take it on Monday during it. There will be a specific time window when the test will be available for you to take. And when you take it, there will also be probably a time limit as to how long you can take the test. So just keep that in mind. Again, we'll have more information, but as soon as you start the test, you'll have usually they put up like a little counter timer. You'll have a certain amount of time to complete the test, just like you would in class if we took it kind of in person. Any other questions on anything else? And I guess the last reminder would be that if you do have lab today on Monday, I believe Dr. Tyler has put up a link for you to sort of meet with her for lab period. She may talk about some stuff regarding lab. And then I believe Wednesday people, that if you have lab on Wednesday, technically, there's a separate link that you should follow on Wednesday to go to lab and sort of meet with her just like we're doing right now. So she could talk about the lab and what you need to do. So although we're sort of doing it online, just to keep everybody sort of straight in terms of not everybody all at once, in terms of the lab period, if you're on Monday, you should still go to the Monday. If you're on Wednesday, you should still see the Wednesday. If for some reason you can't see at either of those times, you definitely should reach out to Dr. Tyler and give her let her know, and then she can make some arrangements for you. All right. Any questions on anything else? All right. So this is again how lectures are going to be. Hopefully, it wasn't too bad. It looks like we had a good crowd show up, which is good. Other than that, I'm going to pretty much stop this lecture at this point. Have a good rest of your day. I'll see everybody back here Wednesday about 7:35. Thank you. You have a nice one too. Have a good day, everybody. Don't forget to go to lab if you have it today. You're welcome. Thank you, everybody. Have a good day.